All right, welcome. Today, we're going to pull back the curtain on a piece of equipment that's absolutely essential out on a well site. But, it doesn't always get the spotlight. We're talking about well site heaters. And trust me, without these unseen guardians, a whole lot of very expensive operations would literally freeze in their tracks. So, let's get into it. So, picture this. You've got a multi-million-dollar well, everything's humming along. What's the one thing that could just stop it cold? Is it some huge catastrophic mechanical failure? A big geological surprise? Well, sometimes the biggest threat is a lot quieter. It's a lot colder. And it all comes down to a problem with flow. And here they are. Meet the pipeline villains. First up, you've got hydrates. Think of these as nasty ice-like crystals that can form out of nowhere when gas and water mix under the wrong conditions. They can create a plug that's as solid as a rock. Then you've got high viscosity, basically oil that gets so thick and goopy it's like trying to pump molasses in winter. And finally, foam. This stuff can create chaos downstream, totally messing with your separation process. These three are the silent killers of a smooth operation. So how do you fight back against these guys? It's actually pretty simple. You turn up the heat. And this is exactly where well site heaters step in. They are the unsung heroes of the well site, making sure everything keeps moving just the way it's supposed to. So what is a well site heater, really? The easiest way to think about it is like a giant industrial strength water heater for everything coming out of the well. Its whole job is to safely raise the temperature of that raw mixture of oil, gas, and water, what we call the well effluent. Why? To stop those blockages we just talked about and to get the fluids to a state where they're way easier to handle. It's a cornerstone of both safety and efficiency out there. Now, as you might guess, not all heaters are created equal. In the world of well testing and production, we really run into two main types, and then go about their business in completely different ways. So let's meet the two main players, the indirect heater and the steam exchanger. And this really lays it out perfectly. On the one hand, you have the indirect heater, or IHT. It's got its own diesel burner on board that heats up a big bath of water or glycol. The well flow then runs through coils submerged in that hot bath. The analogy is spot on. It's basically a giant industrial double boiler. Then on the other hand, you have the steam exchanger, or STX. This guy relies on an external boiler to feed it high-temperature steam. The steam fills the shell and heats the coils that way. It's more like a super-powered radiator. So let's pop the hood on the IHT for a second. It's a really self-contained unit. You've got your own diesel-fired burner providing the heat. That heat goes through a fire tube into the surrounding water or glycol mix. That's your heating medium. Then, that hot bath heats the coils with the well effluent. All it really needs is diesel to run the burner and an electrical supply. And of course, a piece of equipment this important has to be built to a certain standard. In this case, API specification 12K. Now, the steam exchanger, the STX, is a totally different beast. Its heat source is external. You need a big boiler somewhere else on location making the steam. That high-pressure steam gets injected, and it is an incredibly efficient way to transfer a ton of heat really fast. One of the keys to its efficiency is this really clever little device called a steam trap. See, as steam cools, it turns back into water, or condensate. The steam trap automatically lets that water drain out, but keeps the high-pressure steam in, so you're not wasting any energy. And being a shell and tube exchanger, it falls under a different standard, API 660. Okay, so knowing how they work is one thing, but using them safely out in the field, that's a whole other ballgame. So let's walk through the playbook. From the initial setup to getting it running, this is where following procedure is absolutely everything. Rigging up an indirect heater follows a very strict checklist for a reason. First, you get the chimney put together, and you have to make sure the spark arrestor is on. Then you fill the vessel up so the coils are completely covered. Now, step 3, this one is mission critical. You have to purge the fire tube with compressed air. This blows out any flammable vapors that could be hanging around in there, which prevents a really dangerous situation when you go to fire up the burner. Once that's done, you're clear to connect your diesel, your power, and your grounding lines. And here is a piece of advice that will save you a world of headaches. When a well first comes on, it's not just clean oil and gas. It's often full of mud, sand, and all sorts of junk from the drilling process. You always bypass the heater during this initial cleanup. If you send that mess through those delicate coils, you'll clog them up in a heartbeat, and your heater is basically a giant useless metal box. All right, once the flow is clean, bringing the heater online isn't just a matter of flipping a switch. There is a very specific safety-critical sequence. You do it in this order, no exceptions. First, you open the outlet valve. Why? Because as soon as that fluid starts to heat up, it's going to expand, and that pressure needs somewhere to go. Then, you open the inlet valve to let the flow in. And finally, you slowly, and I mean slowly, close the bypass valve, gently sending the flow through the heater, watching your pressure gauges the entire time.
So, how hot do these things actually get? Well, the typical maximum operating temperature is 80 degrees Celsius, or about 176 Fahrenheit. In fact, these units have a safety thermostat built right in. If the water bath gets any hotter than that, it'll automatically shut the whole system down. It's a critical safety feature to prevent overheating.
So, we've gone through the what and the how. Let's take a step back and really lock in the why. Why does all this matter? What are the core benefits that make these heaters just non-negotiables on a well site? It really all comes back to defeating those pipeline villains we met at the beginning. You're heating the gas to keep it above that hydrate formation temperature so you don't get those dangerous ice plugs. You're heating heavy oil to lower its viscosity, to thin it out so it flows easily and separates properly. And you're heating the mixture to help break down any foam, letting trapped gas escape so you get a nice, stable flow heading to the separator. It solves all three big problems. And look, because this gear is so vital to a safe operation, you can't just set it and forget it. There are really strict maintenance standards. Every 5 years, these units have to go through what's called a major survey. We're talking detailed inspections, pressure tests, the whole shebang, to make sure they're still certified and fit for service. It's a non-negotiable part of keeping people and the environment safe. So if you take one thing away today, let it be this. Yeah, we talk about efficiency and flow rates, and that's all important. But the number one reason for proper heating is safety. Period. Preventing a catastrophic pressure buildup from a hydrate plug and just ensuring the stable operation of the entire facility, that's what makes this equipment a fundamental pillar of a safe work site. You know, heating the well effluent is that first critical step. It gets the whole mixture into a nice, manageable state. But it kind of begs the next question, right? Once everything is warm and flowing smoothly, how do you actually separate the oil from the gas and the gas from the water? Well, that sounds like a topic for our next explainer. Thanks for tuning in.